So we can solve logarithmic functions kind of like how we did the exponential equations yesterday. This first one, notice I have ln on both sides, and then I have some things in parentheses. Since I have the same logarithm on both sides, I can just take my insides and set equal. Okay, so what I'm going to do is I'm going to have 4x minus 7 equals x plus 5. Okay. So then I want to solve this just like a normal algebra problem. I'm going to subtract x on both sides. That's going to get me 3x minus 7 equals 5. And then I want to go ahead and add 7 to both sides. Then I want to go ahead and divide by 3, which gets me x equals 4. Okay. On number 2, I have a log base 2 and then a number on the other side. So when this happens, I want to rewrite it as an exponential. Okay, so I can rewrite this as 2 because my log base was 2, so my base of my exponential is going to be 2 with an exponent of 3, and then it's going to equal 5x minus 17. Remember, the exponent and the argument always switch spots. Then I want to figure out what is 2 cubed. 8. So I'm going to rewrite that. I have 8 equals 5x minus 17. Then what would I want to do to get x alone next? 8 plus 17 is 25. Then I want to go ahead and divide both sides by 5, which gets me x equals what's 25 divided by 5?
6.
What? 5. Questions on number 2? Okay, so sometimes if I have 2 logarithms, I want to use 2 or more logarithms. I want to use log properties to condense. So when we have multiple logs, use properties to condense. So right now in between these two, I have a plus sign. Remember from our notes on Tuesday that whenever I have a plus sign in between, I can multiply the arguments inside. So what I'm going to do is I'm going to rewrite this as one logarithm. And I'm going to multiply those arguments inside. So I'm going to have 2x times x minus 5, and it still equals 2. Bless you. Okay, then I want to go ahead and actually multiply the pieces in here. What is 2x times x? And then 2x times negative 5? Negative 10x. And this still equals 2. Then I want to go ahead and just like I did in number 2, where I rewrote it as a logarithm, where I turned the logarithm into an exponential function, I want to do the same thing here. Notice I don't have a little tiny number. Remember, when there's no number, it's assumed to be 10. So I can rewrite this. It's going to be 10, and then this 2 is going to become my exponent, and it's going to equal my argument. Okay, what is 10 squared? 100. So then I want to go ahead, because this is quadratic, I want to get everything over on the same side. So I'm going to subtract 100 on both sides. On my left side, it's going to cancel out. On my right side, there's nothing I can combine it with, so it's just going to go on the end. Then notice every single number is even. 2, 10, and 100 are all even, so I can divide everything by 2 to get rid of it and make this easier to factor. Okay. This gets me 0 on the left. X squared. What's 10 divided by 2? Negative 5. Negative 100 divided by 2? Negative 50. Then I want to factor. I'm looking for what multiplies to negative 50 and adds up to negative 5. You guys have any ideas? Close. Negative 10 and positive 5. Positive 5. Then I want to take each of these and set them equal to 0. Nope. Nope. And I would solve them. On the first one, I add 10 to both sides. On the second one, I subtract 5. When I get multiple answers, I need to go back and check my answer. So I am going to do my check. I'm going to first start off with the 10, and I plug back into the original. So I am going to do log of 2, and then I'm going to multiply by that 10, but I'm going to write it in a different color to show that I'm plugging it in. Log 10 minus 5 equals 2. And then I do 2 times 20, 2 times 10, which gives me 20. I was thinking of the answer. 10 minus 5 gives me 5. And this equals 2. So because all of my logarithms are positive, I know this will work. Okay, so 10 works. Now I need to go ahead and check the 5. And it was a negative 5. So 2 times negative 5 gives me negative 10. And then negative 5 minus negative 5 gives me negative 10. So this one doesn't work. Okay, so on number 4, I can go ahead and because it's just 2 of the same on both sides, I can go ahead and set these equal. I am going to have 5x plus 2 equals x plus 10. Then I want to go ahead and subtract x on both sides. This gets me 4x plus 2 equals 10. Then I want to go ahead and subtract 2 on both sides. I get 4x equals 8. And I divide both sides by 4. This gets me x equals 2. On number 5, I want to rewrite this one as an exponential. I'm going to have 3 to the 4th equals 10x minus 9. 3 to the 4th is 81. Then I want to go ahead and add 9 to both sides. I get 90. Then I divide both sides by 10. And I get x equals 9. Okay, on number 6, I want to use my logarithmic properties to condense. So I'm going to have log base 6, and then 6x times x minus 1 equals 2. That 2 is ugly, I'm so sorry. Then I want to go ahead and multiply the inside parts of my argument. So I have 6x times x is going to give me 6x squared. 6x times negative 1 gives me negative 6x, and it still equals 2. Then I can use my logarithmic properties, or not logarithmic properties, I can turn it back into an exponential because of the definition of being a logarithm. So I'm going to have 6 squared equals 6x squared minus, there's a lot of 6's in this problem, 6x. remember there being so many. Anyways, 6 squared is what? 36. Then I want to get my terms all over on the same side. So I'm going to subtract 36 on both sides. I get 0 equals 6x squared minus 6x minus 36. What do I know about 6, 6, and 36? What number divides them all? 6. So 0 divided by 6 is 0. 6x squared divided by 6 is x squared. 6x divided by 6 is just negative x. And negative 36 divided by 6 is negative 6. So I'm looking for what multiplies to negative 6 and adds up to negative 1. Then I want to take each of those pieces and set them equal to 0. On the first one, I add 3 to both sides. I get x equals 3. On the second one, I subtract 2 on both sides, and I get x equals negative 2. Because I have 2 answers, I want to go ahead and check. So my original equation was log base 6 of 6x, so I'll plug in my x in a second, plus log base 6 of x minus 1 equals 2. The first number I'm going to check is my 3. So 6 times 3 gives me 18. 3 minus 1 is 2. Does this one work? Yeah, because 18 and 2 are both positive. Then I'm going to go ahead and check negative 2. So I'm going to have log base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1. Six times negative 2 is negative 12. Negative 2 minus 1 is negative 3. Does this one work? No. Questions?